stuff in Unity, and I'll be here to answer any questions, see if you guys need any help. So, to start us off, kind of the prerequisites. Um, it's I'm assuming that you've got VS Code or some kind of compiler that can work with C# already installed. If not, that's all right. Just you might be a bit behind if you want to install it, or you can just watch. Same goes for Unity. I kind of got the expectation. I'm kind of expecting that you have it already. I'm going to go over really quickly how to install it. But if you don't have it, that's all right. You can always watch, or you might need to, or if you want to install it, you might be a bit behind, but this will be recorded. So you feel free to go over it again later. So first, installing Unity, you're just going to want to go to unity.com/download, click on download. Once it's downloaded, open the downloaded file, let it access your computer and just follow the steps. Once it is installed, you're going to want to go to UnityHub, open it. It's going to be called UnityHub. You're going to want to go to installs, click on install editor, select Unity 6, and let it install. Essentially, this first bit installs the Unity Hub, which is where all of our projects are saved, where we can kind of access all of our different Unity projects. And then Unity 6, this is the editor project will be actually edited in. So as I said, I'm going to kind of keep going, but feel free to just watch or to install this later, and there will be a recording if you want to hear everything again, if you do decide to install this later. So yeah. So first, the question, is game development helpful even if you don't want to become a game developer? The answer is absolutely. So not first of all, you learn C#. Some game engines might use a different language, but we're going to be using Unity, and Unity is in C#. This is a great language for a stepping stone to more complex languages like C or C++, and those complex languages can be super versatile and are used across a lot of different fields. So learning game development can be super helpful in just getting yourself started with that. You'll also be learning a lot about optimization, databases, networking, all of that, especially not so much today, but especially as you work with multiplayer games or larger games, you end up working a lot of optimization and networking. We will be working with the Unity database, so learning how to access Unity, different things from the database and working with those, all of which are super useful in all fields of computer science. And finally, you can also show off visually to employers. Super great. Sometimes employers don't know, the people that are actually hiring you might not know how to program or how different code works. And programming in making some small game can be a really visual way to show off what you know, and also to just show even people that do know a lot that you know all of these things about networking, optimization, the working with complex languages, etc. So moving on to planning our game, before you start making a game, the first step, the most important step, is to plan ahead. So I recommend creating a map of your game. Doesn't need to look like this, of course. but having kind of a core idea at the center, at the top, and important features, and then optional features outside. And you can have this could be 3 rows, this could be a million rows, whatever. Oh, um, can you all hear me? Okay, sorry. Thank you. I'll keep going then. Yes, so you've got the core idea, the important features. So you kind of want to map things out. That way you can kind of understand what your game is, both understand what your game is in its essence, but also this helps you limit yourself so that you're not making your game forever, and also especially helpful if you have a time limit on when you need the game. For example, if you're making a game jam, or even if you're working for someone and making a game, um, this helps you set yourself a limit and know, like, okay, I need to implement my core idea, and it's important to get my features in. But once you start getting to optional features, it isn't as important. You might be able to just stop there, release your game, and you can always update it again later if you really want to. So for our game, the game we'll be looking at, we're the core feature is that we're escaping a maze. Um, if we weren't escaping a maze, this would be an entirely different game. So that's really the core of our game. It's important that our game be first person and 3D. First person because it wouldn't be as horror vibes if if it weren't first person. You might also, if you had like a top down view, it wouldn't work as a maze. And 3D is less of an important decision, but rather a decision you need to make first, because if you're designing a game and you design it all in 2D, and then later on you decide you want to make it 3D, that's going to be a long process of moving everything over. So deciding what kind of dimension, or whether you want to make a VR game, um, deciding that can be, or a mobile game can be, a pretty important first step. And then we've got some optional features. We want some enemies, randomly generated maze, because otherwise you're just doing the same maze over and over. You want a win-lose condition. You don't want it to be just like you're running around a maze, you escape, nothing really happens. You want something to happen when you win or when you lose. And you want some animation just to make it look nice. Now, in the game we'll be looking at, animation isn't actually implemented, and that kind of shows animation is an optional feature. It makes the game look nice, but it isn't required for the game, and so we just don't have it. Um, Now, getting to actually looking at the game itself, um, we're going to be opening Unity. So I'm going to switch over to Unity Hub. You can open Unity Hub. It should look something along these lines. Um, and so you've got your 4 different tabs. You might need to log in. If you haven't already, just make an account with Unity. It should be a pretty simple process. But yes, you have 4 tabs here: projects, installs, learn, and community. Projects is the one we'll be focusing on, but learn has a bunch of tutorials which are super helpful. Unity is really good for beginners because it's got such a large community. Same goes for community. That's even helpful outside of just your Unity starting off. You'll always be able to use the large community in Unity. So the first step we're going to be doing is we're just going to click on go back to projects and click on new project. Wait for it to load up. We want to make sure we've selected Universal 3D. Don't worry about the rest of it. Obviously, 2D is for two-dimensional and mobile and VR. High definition is for if you're making a very doing specialized stuff, but we just need Universal 3D. We've got to name our project. I'm going to call mine GDSC UTM Maze. Whoops, Maze Escape. Sorry, one moment. You want to make sure you've got a location. So I've got mine stored in my Unity folder, which is where Unity Hub is also stored. It'll create a new folder with the same name as your project name, and that'll be where all of your files are stored. And you want to make sure to uncheck Connect to Unity Cloud. Once that's all ready, and so long as there's no issues, just create project. Now this takes a while. So what we're going to do is we're actually going to go back to our slides and go over some game engines. So we're going to start with some of the popular ones. The one we're going to be working with is Unity. So Unity's great for being very versatile. You can do 3D, you can do 2D games, you can do VR games. You can really do practically any game. It's also super popular, so there's plenty of support, tutorials, and such to help get you started. Unity is really good for getting you started. However, it does have a lot of features. So if you're not working with a tutorial and you're just trying to figure things out on your own, it can be pretty intimidating. And when you're trying to make a commercial game or a large game, you're going to have to deal with licensing fees. And Unity's been doing some not so great stuff with licensing fees recently, you may have heard of. So that can be a concern. Otherwise, there's also Godot. Godot is open source and it uses C# and a language called GD script. C#, I've already explained, it's great. GD script is very helpful if you're starting off because it's a much simpler language, more like Python. And it's GD script as in Godot script, specifically within Godot. However, Godot does have a smaller user base than other options, and it's not great. It does have the capability to do 3D stuff, but it's not great at it. It's mainly a 2D engine. Otherwise, we've also got Unreal. Unreal is a 3D engine. It uses Blueprint, which is a visual scripting system. So if you don't like the idea of like programming in C# or C++, this is really good because you can kind of design things more visually, and it might be easier to understand, easier to visualize. Unreal also has a bunch of features for apps. However, it is pretty resource intensive. So if your computer isn't that great, it might not be the best for you, which makes it more, C++ is more complex slightly, and less game engines use it. Most game engines tend to use C#. So that can be a little not great if you're just starting off. So generally, I'd recommend Unity if you're starting off, and then after that, you can kind of find the one that fits your game. There are plenty of other options. So I'm going to go over three real quick. Clausewitz engine is a 3D engine. This is where all Paradox games since 2007 have been made. Click Team Fusion is a 2D engine, and this is where FNAF or Baba Is You were made. And then Decima is a 3D engine. This is where Death Stranding, Horizon Zero Dawn, Until Dawn were made. And there's many other options. So like I went over the three big popular ones, but as you can see, there's many other options. You can surely find the one that works for what you want to make. That tends to be pretty complicated unless you're making something very simple. You might be able to use something like Pygame if you were just making a game in Python. You can also, because Godot is what's it called? Open source ones like Godot so that it functions for you. So yeah, bunch of other options. Now we're going to actually get into the thing. So we're going to be downloading our assets. I'm going to share a link for you all. Give me one moment. I will post it in the chat here. This is a Google Drive link. Just go into the Google Drive and download the file. It should be a Unity package file. This file contains all of the assets and the scripts we'll be using. So this is kind of the game. So yes, download it. Let me know if there's any issues. Otherwise, let's open Unity. Hopefully, at this point, you should have a little icon looks like this. This is the editor, Unity 6. And if we open this, it should look something like this. First thing we're going to do really quick is we're just going to click down here and click Remove README Assets, Proceed. And that's just, those assets are not things we need to worry about. Then once this is done, loading up, we go over to Assets, Import Package and Custom Package, and then we can go and find our package file wherever it's downloaded for you. For me, I downloaded it here. It should say GDSC UTM Maze Escape, and then if we click Open, this should appear. Everything, this is a bunch of different things. Don't worry about what it all means. For now, just make sure that it's all everything's checked off and click Import. This is all of our files. However, you will notice an error appears. The typer namespace Cinemachine does not exist. We need to import another package. However, this one is one from a group that has sent something in Unity itself. So we're just going to go up to Window and Package Manager. This is where we can get packages from. If we go to Unity Registry on the left here, this is where we can get packages from people who have made a bunch of super useful things in Unity. And what we'll be looking for today, or what we'll be using today, is Cinemachine. So just search it up and install it. Cinemachine effectively lets us do a bunch of things with our cameras that we couldn't do in regular Unity. This lets us do things like have multiple cameras or follow our character around. So it's super useful, and we'll go over more specifics of it later. Once it's done loading, there we go. You may notice an error that looks something like this. Essentially a warning saying that this is obsolete. This comes from something in the code that has been deprecated and hasn't been fixed. What we can do is just go over here, click on console, and click this little icon here, and that'll hide the warning because we don't need to care about it right now. But I think now that all of our assets are installed and everything's ready, we should probably go over what's on screen. So, first things first, in the center of our screen, this is what's called our scene view or scene tab. You can see the name over here. This is where we can see what we're building when we're like making our game. It's called scene because when we're building things, we're building them in a scene. When you hear the word scene, think like a location, a level, maybe a start or end screen. And all of those are scenes. So whenever you're like loading into a new level, for example, as far as Unity thinks, then you'll be loading into a new scene. There's also a game tab here. This is where we can see what our game looks like. So when we click play up here, this will appear. This is from the perspective of our camera and is just what the game will look like when it's being played. We've also got the asset store. This is super useful for getting a bunch of assets. It's where some of our assets come from. We'll go over that later. But over on the left here, we have our hierarchy. This contains all of the objects that are in our scene. So right now we have a main camera, a directional light, and a global volume. Our main camera is our camera. This is our view when we're playing. Lighting is a type of lighting. Don't worry too much about why it's directional. This just gives us shadows. And then global volume is complicated, and we're not going to go over it. But it's helpful for a bunch of other things. We can also make new objects by right-clicking and going over to any of the options over here. For example, we can go 3D objects, cube, and we should see a cube appear after it's done loading. A cube appear right in the center here. You can hold right-click on your screen, and you will be able to move around in your view using WASD. You can also zoom out and in. Now, it isn't here on my screen. However, your screen might look something like this. It might have this and this and this on your screen. If you do see these, just grab those two bars, and just move it all up here. It's not particularly important except for this, which is our tools that we can use. The tool we're currently using is our move tool, which means that when we've got our cube selected, whether it be like that or we could select it like this, and we can move it around using the arrows. We can also use our rotate tool to rotate it, scale to scale it around, and this is these two are just more complex versions of the tools already mentioned. The view tool just lets you move around like that, move your camera around. So what you might have noticed on the right here is the inspector. So when we click on an object, any of our objects in our scene, um, if you look at the inspector, it has a bunch of information about the object, kind of like the settings of the object. We've got the name, tags and layers we won't worry about right now. And then everything here is what's called a component. So our transform component gives us our position, our rotation, and our scale. We can right click and tap reset, and that will reset us to 0, 0, 0, 0, 1, 1, scale of 1, 1. We can also link our scale, which means if we increase our scale, our object will get bigger all at the same amount. Finally, you can actually go into transform and put in specific numbers here. So if you have, like, you could put in 3, 2, whatever. And if I just reset this for a sec, you can also hover over one of the icons here and until you see those two little arrows next to the mouse, and you can click and drag, and it'll let you kind of drag those values around, which is super helpful if you're just like editing things in here. We'll go over the exact components, but essentially components are all of our settings for our object, maybe things that might give it gravity, or such as a rigid body that gives our objects gravity, or names, tags, such and such. And then finally, at the bottom here, we have a project tab and a console tab. We already took a quick look at the console tab, but essentially this is where any errors, warnings, or debug messages will appear. You can hide or show your warnings, errors, and debug messages over here. And this will let you hide things if you don't need, if they're not relevant. The difference between warnings and errors is that warnings are just things that could be an issue, whereas errors will stop your game from running. So if you have an error, Unity will not allow your game to run because it's inherently broken. So generally, I hide my warnings, but unless I need them, and I always keep my errors open or unhidden. The other tab is the project tab. This is essentially the file manager for your project. So your main file that you need to focus on is assets. Packages you can just hide away. As our assets contain all of our assets. This is the file called the input system. This just lets us map our different kinds of movement, like pressing WASD. We can map that to be movement. That's already done by default, so we can just leave that be. Then the other main thing to take a look at is our scenes. As I said, we're working in a scene, so you can have multiple scenes, and each of these are kind of a level. We're in what's called, you can see the name of your scene here, 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 sample scene. However, we've got a scene already built called Sandbox that we'll take a look at in just 1 second. First, we can go over to resources, and then prefabs. And this has all of our prefabs. What's a prefab? Prefabs are essentially objects in the game, like our little cube here. We could rename him Potato. by going over here and just changing the name. Our little cube called Potato, he only exists in this scene. So if we went to our other scene, Sandbox, there would be no way to access him. However, if you drag him over into our prefabs folder, you will notice that he now has a little blue icon. He is now a prefab, which means that if we went into Sandbox scene, we could simply drag him in and he would exist in both scenes. That also means that if we double click on our potato or we click open up here, we can edit things about him in this what's called our prefab view, and we can do all sorts of things, edit him, and when we press Control S to save, go back, and we'll notice that he is different in all of our scenes. So he is connected across all scenes. He will always look and have the same components and such. So for now, we can delete him. We won't need him for Potato. And we are going to go over to scenes, and we're going to double Sandbox. We don't need to save our scene because we've done to make sure you're saving your scene. Otherwise, it will be lost. So before this is what our scene looks like. This is what our game looks like when it's just built as it is. What we have is, let me see here, sorry. Oh, yes. First, we just need to go into Edit, Project Settings, and click on Editor, scroll down to Enter Play Mode Settings, and we're going to set this to Do Not Reload Domain or C. The reason we do this is because the way that C# works and Unity works with it is that it compiles and prepares everything and loads our domain or scene whenever we save and prepare our files. But if we have it set to reload domain or scene when entering play mode, that means that whenever we click play, it'll do all that process again, and that can really slow things down. So we make sure it's on do not reload so that things are a little faster. Now, so what we have here, we have all of our objects in our little hierarchy, and I'm just going to quickly. First, sorry, let's just see what the game looks like. So if we go over here and press play, if you press WASD, you'll notice you can move around, all sorts of stuff. And there's a weird thing. That's a bunch of different things. That's more than we need to focus on right now. So let's start by going through all of our objects. Our main camera has been turned into a Cinemachine brain. So you'll notice that by the little Cinemachine brain component that we can see in our inspector. This is a component. It's essentially makes our camera into a controller for all of our different pieces, for all of our cameras. This kind of works as a controller. And so essentially, now our main camera is no longer really a camera. It's more like a controller for a bunch of other cameras which are called Cinemachine or virtual cameras. It lets it, and so our main camera is now controlling which camera we're seeing through in the game, and some other stuff like that. Environment is a is what's called an empty object. This is essentially, if you right click and you can click create empty, this is an empty object which does nothing. It doesn't have gravity. It doesn't look like anything. It's just empty, but it has children components of a ground and some walls, which means that now if we go over to our movement and move things around, you'll notice that if we move environment around, well, it should move around our ground and our walls as well. Seems to be a little buggy right now, but that's all right. Our ground is just what's called a plane object. Right click, 3D object, plane. It's just a flat surface, and it has a couple components. This is what anything that is visible has what's called a mesh renderer, and this makes things visible. If we disable it, it just stops appearing. This is more visible when we'll look at the walls. But the other thing it has is a mesh collider. This makes sure that your character isn't going to fall through the ground by making the ground have a collider. And last but not least, you've got a material. This works with the mesh renderer, and effectively, if we go back into our project, materials, and go over to resources, materials, you'll notice a bunch of little orbs here. Each of these are a kind of color could be a color, could be a texture for our object. So we're using the ground material to give our ground a brown color. It's blue right now because it's being buggy, but don't worry about that. Then our walls is another empty object that contains a bunch of walls. Each of these are similar to the ground, except that they're a box instead of a instead of a plane, and they have a tag called finish. This lets us know when we're colliding with something, lets us understand what we're colliding with much quicker. And that's generally what most objects have. We've got a Win camera here, and this is one of those Cinemachine cameras that our main camera is going to be looking through. This camera, if I double click on it, it should bring us over to it. And you'll notice that it's floating above. And this is kind of our camera that we go to once we've won. If we go back to our player, we've also got an object called maze spawner. This is another empty object, and it has a script. This is complicated, but essentially just lets us generate our maze randomly by having this script attached to this empty object. This script will randomly generate our maze and spawn enemies at a certain amount of time. And then our global volume and directional light we've gone over. Our nav mesh surface, this is actually, we'll go over the player real quick first. Our player has a rigid body. This is another empty object that contains a player rig, which is the model for our player, and a player camera, which is another Cinemachine camera. This one gives us our first person view. Um, and our empty player object has a rigid body to give our player gravity. This is also what we use to move around our player. It also has a collider to deal with collisions, and it has a mover and player collision script, which moves the player and deals with the collisions for the player. Then our nav mesh surface. This is, oh, I see why it's blue. The ground is blue because this is activated. If I disable this, you will notice the ground is brown. Essentially, nav mesh surface is a blue field. It calculates where in our scene can an AI, in our case, it's going to be our enemy, which we'll go over in a sec, where they're allowed to move to. Currently, it's blue because it's covering the entire. Our AI can move pretty much anywhere. Uh, the way that we kind of make this is we just create a nav mesh surface by going AI nav mesh surface, and then we go over here and we click bake, and this just makes the nav mesh surface read the world and tell us where our AI is allowed to move. Finally, where is our enemy? The answer is if we go into resources, prefabs, we'll notice that the enemy is a prefab. That's because our maze spawner is actually going to load our enemy as well as the maze modules that are over here. And it's going to load the enemy at runtime, which is when the game is playing. The enemy prefab, however, has a script for targeting because it has a nav mesh agent component. This effectively works with the nav mesh to move the AI towards a certain location. That location is determined by our little enemy script here. So that's all of our objects. Because we're a little low on time, I'm going to show you how to make the game, which we call sorry, which we call building the game. And then I'll go over the scripts afterwards. I will also post the challenges if you want to work on those in just a sec. But first, let's go over once you've got a game, how do you build it? How do you make it into an executable file so that you don't have to open Unity and play it here. You can actually play it with a file, and then you can upload that file to like Steam or wherever. So what you do is you go to File, Build Profiles, and this is a build profile. What we're looking at is Windows because this is what most games are built for. And what you should see is here a scene list. This is the important bit. This is a list of all of the scenes in our game. Um, Currently, it just has sample scene, which we're not actually going to be using. We're going to be using sandbox instead. So what we want to do is open scene list, and we're just going to click add open scene. And then we're going to uncheck sample scene. Now, if we go back to Windows, you'll notice we've got scene sandbox checked. This means that when we build our game, it will build this scene into our game, and this is where we'll start off. We can tell where we're starting off because of that little number here. This is the build index of our scene. Essentially, if you have multiple scenes, it's going to start at 0, and it's kind of the order that your scenes are in. You can do some stuff to load these scenes in order, or load the next scene, or use this number to load whatever scene you want. Um, then once you've got the right scene list, and everything seems good, you just want to go up here and click build and run, and then make a folder. So I've already got this done. I'm going to go over to my documents, and where is it? Here it is. I made a folder called GDSC UTM Workshop Unity Game Build, and you're going to want to make a new folder, name it something that you can recognize as this is what my game is, and then you want to select that folder. And I'm not going to do it because it's going to take a while, but you select that folder, and then it will start building, and it'll take a couple minutes, more longer depending on how big your game is. And you'll have, once it's done, you will have a full file just like, if I go over to, sorry, documents, go over to my Unity game build, you should see something like this, or it might say .exe. Its name should be different. I built this in a different version, but its name should be the same as your project name. And when you double click it, you should get, it should start opening an exe file. If it doesn't mind, there we go. That looks like this. It should say made with Unity, and then your game opens, and you can move around in the game, and you're actually in the game. And then you can upload this to Steam and whatever as you will. You will need to click Alt F4 at the moment because we don't have a way to exit the game. Yes. So that's how you build a game. That's how you kind of make assets and then build your game. We're pretty low on time, so I'm going to go over how the scripts are made. But you now have the knowledge to be able to start yourself off, and kind of, you know how objects work, how a scene works, you know how to add components, how to make yourself an environment and a camera and all that. So at this point, you know how to start your process. And there's many other tutorials if you're kind of done now. That's completely fair. If you need to leave, there's plenty of other tutorials for learning how to make characters move around. You're free to look through the files made and kind of read through it, but I'm going to go over it now, kind of over time. Yes, one quick thing I'll note is that this little star icon next to our thing indicates that our scene has not been saved. So we just want to Control S to make sure that that's saved. That's good, the current version. But yes, I will post the challenges once I'm done going through the scripts. But yeah, thank you for joining me. I hope that you've learned. Sorry. I hope that you've learned some stuff. Thank you for coming. If there are any questions, please let me know, and then I'll go through how all the scripts work. Yeah, I'll take a minute just in case anyone has any questions. Yeah. Sorry, this has gone through several versions, so this was that I did not realize this would go so over time, but How do you make an exit like winning the game? So that happens in our script. I will actually go over to that now. So if we go over to scripts, and what the one that has our exit is our player collision. Uh, oops, I accidentally clicked on the wrong thing, and now everything's weird. That's fine. Uh, double click on player collision. Uh, it should open in whatever uh, whatever code thing you're using. So I'm using VS Code. It should open in that. And essentially, the important thing for making an exit is that we use a, so I should really quickly go through using. When you see using up here, that's kind of like Python's import. So we're kind of importing Unity's engine and Cinemachine and scene management. Uh, the public class, this is essentially the name. This should be the same as the name of your file. If you change the name of your script after you've set it up, uh, then it will have issues because these two aren't the same and you will run into issues. But this is essentially your class. And then each of these where it says void or private void, that's a method. Start and on collision enter are both methods that Unity uses. So the one we're going to look at is on collision enter, which takes in a collision other. So this is essentially when we collide with another object, or more accurately, when the object that our script is attached to, which in this case is our player, um, collides with another object, then that other object will come in as other. And what we do is we check if the other object's game tag is finish, which is the same game tag as this would. There we go. This is the same game tag as our walls have. If you look at our walls, they have the tag finish. So it checks if those have that tag, and then it calls a method. And then at that point, you can have your kind of exiting the game or winning. Um, if you want to exit the game, you have a function called application.quit. This won't work in when you click play in Unity. Like application.quit won't do anything. However, when you have it like built as a file, you can have it so that once you've reached the finish line, you call application.quit, and that will quit the game essentially. Um, the way it's currently built, what we're doing is we're taking in a bunch of different things. This so the way that Oh yeah, sorry, I see you're typing. I will wait a sec. Drink some water. Real quick while you're typing, the way that C# works is that it's statically typed, which means that you need to put the type of your variable um, when you're making the variable. So here our player body has to be a game object, so our variables have a specific type. Um, so okay, so when you're turning the ground brown, essentially, um, I what you can go over to your ground, and your ground should have a material. it should be called ground. Um, uh, this material is in materials, it's brown. We could edit it to change the color. If you want your ground to be blue, you could make it blue or whatever color you'd prefer. I'm going to just leave it as brown, but the reason that the ground looks blue, even though it is brown, is because, where is it? Nav mesh surface is kind of covering the ground. It If you can untick it and you'll actually see the ground itself, but the nav mesh surface is just coloring the ground, and the nav mesh surface is always. Um, how do you configure these scripts in Unity? And as in, how do you make a script run on certain event occurs? So that comes that comes down to Unity has a bunch of different methods or functions that happen at specific times. The first ones you start with when you make a new script. So I'm just going to real quick go into scripts, right click, right click, create mono behavior script. And I'm just going to call it test. When you make a script, it will always start off with two methods, start and update. Start will happen when the Unity essentially calls start when the thing that this script is attached to loads. So the only once when the thing is like first loaded in, and then update is called Unity calls every single frame. But there's a bunch of other ones like on collision enter is when you collide with something. Or you can kind of make your own in a way. So if I look at mover, is it? Yeah, mover. So for mover, we've got update and in update where I'll go over this a bit more, but we're reading our input action is just like from that thing I showed at the very beginning, the let me show it. The input system file, whatever we've loaded in there as move, that's going to be flat movement action. So in this case, it's going to be WASD. It reads that as a vector2, which is just two kind of coordinates. So however much we're moving in the left and right direction, and however much we're moving in the forwards backwards direction, and it's kind of like a tuple. And then we can have our own methods and then we've got a method to essentially move the player around, rotate the player. So you can either look for methods that already exist in Unity, like start, update, fixed update, on collision enter, things like that. Or you can set things up so that like you could check if certain buttons have been pressed by using input system, and then make a method that does things based off of that. Does that answer your question? No worries. I'm glad. Yeah, I'm gonna real quick go through the scripts kind of generally. But if there's any more questions, I will keep an eye on the Discord. Feel free to leave whenever. You're free as always. You're free to leave whenever you wish to. I'm just going to kind of go through this. I didn't realize it would be so short. So the simplest script we have is enemy script. This is attached to our enemy. The way we attach scripts is we just go, say we have a script like test. We want to attach test to our player so that so that we can do things to our player. No worries. Based on so that we can do things with our player based on what it's attached to. We've just got to literally click on this and drag it onto the player. And then we should see, I think I may have accidentally dragged it onto wall 3. I don't know where it's gone. Okay, that's fun. We should see it appear in our components. Here we go, test script. And so we just need to drag it over. I'm actually going to just remove this because it doesn't do anything. But so enemy script is attached to our enemies. What it does is it uses serialized field, which will look like this in Unity. This is a different script, but essentially, actually, if I go over to resources, prefabs, enemy, you'll see the script right here. Serialized field makes a field in Unity that you can access with the name of your variable. So, like for our player, we have our collision. We can set like the game score or the amount of lives that the player has over here in the Unity editor, and these whatever we set here, so long as it's properly saved, will exist also in our once the game is built. So we've got a serialized field here with a target. Essentially, this target is just going to be where our enemy wants to go, and it's got the type transform, because transform is essentially the position, rotation, and scale of an object. So whatever our target is, we're going to get that target's position, scale, and rotation, and we're going to set that to be our target variable. It's also got a navmesh agent type variable called agent, and this is going to be set up to be is going to essentially be that this variable is our component of our enemy. It's going to be our navmesh agent component. That way we can change stuff in our navmesh agent in our component. The way that we get a component is we use get component, and that just gets the component that we've named. That we've named, and set whatever our variable is to be that. I should mention that C# or C languages do things differently from Python. They use semicolons to represent the end of a statement. So at the end, when you say using or import, whatever, you should have a semicolon at the end, or when you're setting a variable, all of that. Most things should have essentially at the end of any action your code is doing. And then methods have these little curly brackets to represent what the method does instead of it being indented. So technically, you can write everything as a single line of code, so long as it's in the right brackets and has the semicolons. Indentation doesn't matter. You don't need things to be in separate lines. It could technically be all one line. That's just something that C# does and C languages in general. But don't do that. it isn't great for making your code look usable. Um, yeah, so in our enemy script, the first thing we use is awake, which is a Unity method. And this happen when awake happens before start. It happens what like right bef- even before the thing is loaded in, but when it's told to load in. What we put in here is tends to be what if we want to like get the component of the thing our script is attached to. So in this case, we're attached to our enemy. If we want to get the component of our enemy or change stuff about our enemy at the very beginning, um, we do that in awake. And if we want to change things or get stuff from a different object, we'd do that in start. That tends to be the case if you're getting stuff from a different object. But if you're not getting stuff from a different object, normally everything is in start. So in awake, what we're doing is we're simply setting our agent variable to be our component navmesh agent, and then we're taking our enemy, um, our enemy's transform. So our enemy's position, scale, everything. We're specifically getting its local scale. So we're getting the scale of our enemy, and we're multiplying. It should be one. It should be one, because that's the regular size of our enemy. And then we're multiplying that by a random dot range, and then we're multiplying it by some random number in this range. Um, as opposed to Python, or sorry, Unity itself has the random function, so you don't need to import any random thing like you would in Python. You can just do random dot range and get that. Then in start, what we're doing is we're finding our object with the tag player, since our player is the only thing to have that tag. If we look at our player, oopsie daisy, cancel. If we look at our player, it's got the tag player. Um, we essentially find that, we do game object dot find object with tag that looks at our scene and finds the object that has that tag. And then we're specifically getting its transform. So again, it's position, scale, such, and we're setting that to be our target. So we're essentially finding our player and setting that to be our target. And then every single frame, we're setting our navmesh agent or our agent, aka our enemy, we're setting its destination to be the target, our player's position. So all of this simply gets our enemy, when our enemy spawns, it sets the player as the target for the enemy, and then every frame it just makes the enemy run towards that target, runs towards our player. So that's the enemy script. That's that's simpler than the other ones. The most important one is our mover script. Again, using public class. The variables it's grabbing is input action, flat move, an input action, a vector2, and a rigid body. Input action is just stores like the concept of an action, like moving around. Input system dot actions dot find action move. So flat movement action is going to be set to our our movement action. So if we move around, it's going to affect our flat movement action. And we've got a vector2, which is essentially a tuple that has two values. In this case, in update, we're setting it to be flat movement action dot read value vector2. This means that our flat movement is essentially going to be the WASD values, a tuple of our WASD values, two values either going to be positive if you're one of the values is going to be positive if you press W, negative if you press S, and the other value is going to be positive if you press D, negative if you press A. And so that this kind of gets us those values. Then our rigid body RB, we're just getting the component rigid body of our player. And yes, sorry, this script is attached to our player. This is how we move our player around. So we're getting our rigid body, and we're going to be essentially pushing our rigid body around to move our player around. We've also got two floats. These may be more recognizable as a type. Floats, movement speed, and we're setting this to be 5 because that's what worked for me. That's what seemed to work best. The F just indicates that this 5 is not an integer, it's a float, because otherwise C# might complain. Then what we're doing is in start, we're setting our flat movement action and our rigid body to be the right thing. We need to do that in start because if we did that up here, it wouldn't work. This happens kind of when when our C# script is compiled, when it's loaded. So every time that we save our script, it'll compile the script, and then what Unity runs isn't really the script itself, but rather like a computerized version of our script that's the compiled version. It makes it faster than Python when it's like loading the script. However, it's slower than Python to like debug and stuff because it needs to recompile every time. So yes, so if what we're doing is, when we're setting these variables up here, we're setting them up when it's being compiled, but input system, none of this exists when it's being compiled. So we need to do it when the object loads in. Then every single frame, we're reading our values of WASD. Then we're using something called fixed update, which is similar to update, except that it happens every time a physics frame happens. So every time that a physics thing happens instead of a frame, we're using that because what we're moving around is our rigid body, and that's a physics object. So we don't want to be doing that. It's good practice to do it in fixed update instead of update. And what we're doing here is we're calling, in every single physics event, we're calling two methods that we made. These are made ourselves, and they don't come from Unity. And it's rotate. We're going to rotate our player, and we're going to move our player. Our rotation takes in a float value, which is just the value of when we're pressing A and D. Positive, it's going to be some float value between A and D, depending on if we're pressing both, one or the other. And so that's going to be that's going to be the flat movement value at index 0. It's going to be our A and D. We're multiplying that value by time.fixed delta time. Essentially, fixed delta time, there's a similar thing in update, which is just time.delta time. And all that does is it gets the amount of time that's happened since the last frame. So this is the amount of time that happened since the last frame. The reason that we use this is because if I real quick go over to Paint, if our game was going at 10 FPS and somebody else's game was going at 100 FPS, what would happen if we didn't have time.fixed delta time or fixed whatever? Let's say we're moving 1 unit when we're pressing whatever we're pressing. Let's say we're moving 1 unit. That value is going to happen every single frame. You're going to be moved by that amount every single frame. So at 10 FPS, you're moving 10 times per second, or there's 10 frames per second. So you're going to end up moving 10 units per second. But if you're at 100 FPS, you're going to be moving at 100 frames per second. So you're going to be moving 100 frames, and so you're going to be moving 100 units per second. But when we when we use delta time, what happens is that what we're multiplying by is the amount of time between frames. So every frame, if you're at 10 FPS, there's 0.1 seconds between each frame. And so each second, you're going to be moving 1 unit 10 times, but each of those times that value is going to be multiplied by 0.1. So you're going to get 1. Oops. 1. And then at 100 frames per second, there's 0.01 seconds between each frame. So you're still moving at 1. And so this kind of makes everybody's game move at the same speed, no matter what speed you're moving at. Oops. Other direct. Hello. There we go. So that's why we multiply by fixed delta time. Then for our movement, it's similar. The reason that we have this new vector 3 thing is because it's something to do with when you're moving position, but effectively, all we're doing is we're taking our whatever we're moving forwards and backwards, and we're multiplying that by time.fixed delta time, and we're making this just means we're making vector 3, which is the same as a vector 2, except it has 3 values instead of 2. And so we're making, essentially, we're telling it we're not going to be moving in the X, we're not going to be moving in the Y, but we are going to be moving in the Z, because Z is forwards and backwards. X is left and right, Z is forwards and backwards, Y is up and down, generally, in Unity. Essentially, when we call these methods, first we rotate our player, so we get our value of our left and right movement multiplied by time.fixed delta time. And then if that value is less than 0, aka if we're moving left, we do this move rotation thing. Don't worry too much about this, but essentially the reason that it's so complicated is because move rotation uses what's called a quaternion. That's kind of Unity's way of saying rotation. But what we have is the way that we can set those is using Eulers or vector threes. Vector threes are Euler type things. Essentially, all we're doing is we're just taking our current rotation and we're adding if we're turning left, we are taking our current rotation and we're adding a negative of our rotation speed, which we set all the way back up here. And then if we're moving right, we're just going to go positive. We're just going to add a positive times our rotation speed. This down and up is just a positive and negative in the right spot. And then we're going to take this and make it into a rotation, and then we move our rotation back. Similar for move position, we're essentially just moving, we're getting pushed, we're taking whatever position we're at currently, and we're adding wherever we want to move to, we're pushing our rigid body, aka our player body, to by taking its current position and adding whatever our movement input is, so forwards, backwards, multiplying that by a movement speed, and we've also got to multiply that by rotation so that the player moves correctly and doesn't rotate and not move in that direction, which is a weird thing that it can do. But that's how we move around. And the reason that we use rigid body and we don't use something like sometimes you'll see transform.translate is that rigid body pushes you, which means that if you're going into a wall, it just pushes you into the wall and you just don't move. But if you're moving your transform values, essentially, if you're moving these values around, you're not being pushed as so much as you're being teleported, which means you can be teleported into the wall and that can screw with your game. Last but not least, the player collision handler. This uses those serialized fields to get our players the thing that, or our player's model. It also grabs from we also give it the color that our player should be when they win and when they lose. And it takes in the camera for the player and the camera for winning. And it sets two integers, the game score and the amount of lives the player has. Public is the same as serialized field. They're pretty much identical. So when we start, what we're doing is we're just getting our win camera that we've set earlier by putting it into our serialized field in Unity. We're getting its component, Cinemachine camera, and we're making its enabled false. So we're disabling it and we're enabling the player camera. This just means that this just makes sure that when we spawn our player in, we're not starting with the win camera where we're watching from above. We're starting from the player's first person perspective. Then we have on collision enter, and this just checks when we've hit something. If the other thing's if the other thing's tag is finish, then we've hit the outside walls and we can set our player's color to win color, and then we can add to our score. What we do is we just increase our score, which we don't do anything with our score currently, but we could in future. Then we disable the player camera and enable the win camera. And then we get component mover just gets the player's movement component. And we disable it so that the player isn't moving around anymore. And essentially, this just makes it so that when we hit the wall, we increase our game score, and then our camera goes up to the sky, and we see like the whole maze, and our player stops moving. Otherwise, if the game object is enemy, notice that we have to say else if instead of elif, different from Python. But if the other game object is the enemy, then we get the player's material. This is just getting the player's model's material, and we're setting it to be the loss color. And then we're going to lose a life, which just lowers the player lives by 1. This plus plus and this minus minus just means add 1 or subtract 1. And then if our player lives are less than or equal to 0, we quit. So if we've been hit by an enemy 3 times in total, then we just quit. If we haven't been hit 3 times yet, then we're going to do this. Essentially, what this does, Scene Manager looks at all of our scenes, which we looked at earlier when we were building our game, and then it loads the scene that we specify, which what we're specifying is simply the current scene. We have to use its name because that's what load scene takes. But essentially, we just reload the scene. So if we're not out of lives, we just reload the scenes. The player goes back to the beginning, and everything starts all over again. The maze generator script is pretty complicated, so I'm not going to go through it, but I'm happy to answer questions if you do read through it. I'm always available to. Sorry, I am always able to answer messages if you have questions about anything here or Unity in general. You feel free to ask me questions whenever. Can't say that I'll necessarily reply immediately, but in time I will. And yeah, that's essentially everything. You've now not only are you able to build your game and your object and make it into an executable file, you also know how to program. This was a very general thing. I was limited on time, but hopefully this gets you the gist of it, and you can use the various other community tools and tutorials to kind of advance your knowledge more. That being said, again, thank you for coming. If you have any questions, let me know. Again, I'm always able to answer, or I'm always happy to take questions. So even if you have a question 5 months from now, feel free to DM me on Discord. And yeah, thank you for coming. I have some challenges. If you want to try them, I'm happy to help. Thank you, Michael. I appreciate it. You've all been great. I will post these challenges in the. I will really quickly post these challenges. Give me one moment. But yes, always feel free to try them out. And let me know if you have any questions while you're doing them or questions in general. Yeah, thank you so much for coming out.